In order to add or subtract two fractions, we must have common denominators. Which means now we're going to look at the second case for adding and subtracting two fractions is when we don't have common denominators. That means we're going to have to rewrite the fractions that were given without changing their value to get common denominators so that we can add them together. In example 8, let's just focus on this idea of finding common denominators. For part A, we have 9/3 and 8/5. We want to focus on those denominators of 3 and 5, and we need to find the least common multiple of 3 and 5, which we have already previously found to be 15, or we could go back and use those factor trees to get the prime factorizations and come up with that least common multiple of 15. What this means is we want to rewrite each fraction with a denominator of 15. The question then becomes, what do we need to multiply the first denominator by to get 15? 3 times 5 would give us 15, so the first denominator needs to get multiplied by 5. To make sure we're not changing the value of the fraction, we need to multiply by the exact same value in the numerator. Because what that means is we're multiplying by 5 over 5, which just reduces to 1. Multiplying by 1 doesn't change the value of a number, it's just going to change how it looks. Similarly, for 8 over 5, we'll need to multiply the denominator by 3 to get 15, so we need to multiply the numerator by 3 as well. That means our first fraction will become 45 over 15, and our second fraction will become 24 over 15. Now we have two fractions with common denominators that are exactly equal to the values that we started with because they would reduce back down to those values. And now we could perform an addition or subtraction step with those two fractions. In part B, we want to do the same thing. We have 6/3 and we have 10/2. The least common multiple of 3 and 2 would be 6, meaning we need to multiply the denominator of the first fraction by 2 and the numerator by 2 to get 12 over 6. And for the second fraction, we'll need to multiply by 3 over 3, which will give us 30 over 6. In part C, we have the fractions 5/2 and 10/6. In this case, the least common multiple is 6, so we'll need to multiply by 3 over 3 so that this first fraction becomes 15 over 6. And the second fraction already has that denominator of 6. So in this case, we have to update the first fraction, but the second fraction is fine, just as written. Now what we want to do is look at finding some common denominators and then actually performing an addition or subtraction step. In part A of example 9, we have -8/5 and -6/9. The least common multiple here would be 45, so we need to multiply the first fraction by 9 over 9, second fraction by 5 over 5. That's going to give us -72 over 45 and -30 over 45, which means we can rewrite this problem as -72 over 45 minus 30 over 45. Since the denominators are now common, our new numerator becomes -72 minus 30 all over that common denominator of 45, which will be negative 102 over 45. Especially as we get into these longer, more multi-step problems, now we need to make sure when we think we're at a final answer with a fraction-based problem, we need to check and see if those values can be reduced. In this case, both the numerator and denominator are divisible by 3, so our fraction in simplest form would actually become negative 34 over 15. In part B, we want to do the same thing. Our common denominator in this case would be 63. So the first fraction we need to multiply by 7 over 7. Second fraction we need to multiply by 9 over 9. And our new problem would become negative 14 over 63 plus 90 over 63. Adding our numerators together, we'll find negative 14 plus 90 over that common denominator of 63 will give us a final answer of 76 over 63. Those values don't reduce, so in this case we have our final answer. In part C, our least common multiple of 2 and 4 would be 4. So the first fraction needs to be multiplied by 2 over 2, but the second fraction already has that common denominator. So this will become negative 10 over 4 minus 3/4 stays the same. We subtract our two numerators divided by that common denominator, and we get negative 13 over 4 as our final answer.